Okay, so we have a third opportunity to see how to use percents as conversions in the factor label method. And we'll apply it to this particular problem that we have right here. First of all, I need a pen. Very nice. And I read the problem and it reads that I have a solution. It's an aqueous solution, so the solvent is water. And it's 22% by mass sugar. So immediately, I'm going to write that down as a part-to-whole ratio. We have 22 parts by mass sugar to every 100 parts by mass of solution. So I will label the units, and I will label the part sugar and the whole solution. So yes, there are 22 mass units of sugar for every 100 mass units of solution. Of course, there are two other implied ratios that may be useful in converting. For instance, the other part, water, would have to comprise the other 78 parts of every 100 parts. So I can also write the ratio 78 mass units of water for 100 mass units of solution. And of course, one of the most useful ratios further derived is you can write the part to other part ratio. There must also be 22 mass units of sugar for every 78 mass units of water. I continue reading and I see I have been given another piece of data, a density, and I want to write it down as well with numbers, and of course it is a ratio. In units, numerator is mass in grams, denominator, volume in cubic centimeters, and it is the density of the solution. So of course both numerator and denominator are labeled solution. Finally, we're told that we have a volume of 3.00 gallons of solution. So step one in the problem solving method has been completed. I have written everything down that I've been given with numbers, units, and labels. I then ask myself what quantity is being requested in the problem, and this specifically says what mass of sugar. And of course, the simplest way to get through a problem is to start with the answer. So I go through my data trying to identify masses of sugar. Well, this is a mass of solution, and this isn't even a mass, it's a volume. This too, gallons, is a volume of solution. I do see a mass of sugar in the numerator of this ratio. I don't see it in the second ratio, but I see it again in the third ratio, mass of sugar. So I'm either going to use this or this ratio as the start of the problem. But I try to look ahead, and if I use this ratio to get the mass of sugar, I'm going to have to cancel the mass of solution. If I use this one, I'm going to have to cancel a mass of water. And this other information I've been given is largely about the solution, so it seems likely that this will be the best starting point. So I rewrite my ratio. 22, and I have to use some sort of mass units, and the only mass units I see in the whole problem are grams, so I'm going to label them grams of sugar per every 100 grams of solution. Essentially, I'm starting with my answer. If I can find a way to eliminate the mass of solution, I will be left with a mass of sugar, which is exactly what I'm looking for. So now I have to cancel this quantity in the denominator of the ratio, and this quantity is specifically a mass of solution. Now I see that in two places. I see a mass of solution here, and I also see a mass of solution here. Now obviously one of these two masses of solution is going to have to cancel my mass of solution. But if I use this one, and I could invert this and put mass of solution over mass of water, I would then have to cancel a mass of water. And I don't appear to be getting any closer to my answer. But if I use this mass of solution to cancel the mass of solution, I would have to cancel a volume of solution. And I've been given a volume of solution, so that seems to be the likely way out. So I'm going to give it a try. 1.200 grams of solution for every centimeter cubed of solution. And this allows me to cancel the mass of solution from the expression, but it has substituted instead a volume of solution. But that's not a problem because I do have another volume of solution that could allow me to cancel once and for all and leave me with my answer, mass of sugar. So the only problem we still face is an inconsistency of units. Gallons are not the same as cubic centimeters, so I need a quick conversion. Of course, I can get immediately to fluid volumes because 1 centimeter cubed of anything, including solution, is the same as a milliliter of that solution. And then, now that I'm talking fluid volumes, I can use the link between British and metric, which passes through liters and gallons. Therefore, I need liters. And I would write milliliters of solution, and the meaning of milli is a 10,000th, or excuse me, a thousandth of a liter of solution. Milliliters cancel, and I now have liters. Well, I can convert that to gallons because 3.785 liters solution are equivalent to 1 gallon of solution. Now that the only thing remaining in the problem that I don't want is still a volume of solution expressed in units of gallons, I can use this volume of solution expressed in gallons to cancel once and for all. And I would multiply up here, though I'm running out of space, by 3.00 gallons of solution. And the gallons of solution in the numerator would cancel the gallons of solution in the denominator, leaving me with a mass of sugar. And of course, the fifth step of the mechanism of solving problems by this method would be to see if there are specific units requested for that mass of sugar. And there are none. It simply says what mass of sugar. And since grams are units of mass, I'm going to go no further. And to get my final answer, I would simply divide 22 by 100, multiply by 1.2. I would then divide by 10 to the negative third, multiply by 3.785, multiply by 3 gallons. And with 3 measured digits and 4 measured digits, and this is not a precise conversion, so it has 4 measured digits, and my final measurement has 3 digits. I'd want 3 digits in the answer. And I round off 2.99772 times 10 to the 4th to 3.00 times 10 to the 4th, and my units, of course, are grams of sugar. So once again, by writing all the data down as numbers, units with labels, and making sure to use anything that's a ratio, like a percent conversion or a density, as a ratio when I do this step, and then I simply ask what quantity I'm trying to find. If I've correctly labeled everything, I can look at the units and find the quantity of the substance I'm interested in. In this case, a mass of sugar. It stood right out, and I knew immediately how to start the problem. And then the rest of the problem is 2 steps, namely canceling quantities that came along for the ride but you do not want in the answer, by also fishing through the data for the quantity that would cancel that quantity. And then at the very end, though it didn't apply in this particular instance, when I got to the end and had my mass of sugar, because this did cancel, I just checked to see if the units were the specific units requested. No specific units were requested, so I can just leave the units that I had. Had the problem been worded instead, what mass in pounds of sugar is there in 3 gallons of the solution, I would have had a few more steps, because I would have had to convert these grams of sugar remaining through to kilograms and eventually pounds, and record that as the answer.